Hello world, Christoph here. I'm here to do my test corrections for physics that are due tonight. So, let's get started. Recently on the Unit 1 exam, I received a score of 15 out of 20, and I'm looking to revise this to get half the score. So, let's begin. So, on the multiple choice section, I missed problem 2. So this question reads, an ideal gas with molecules of mass m is contained in a cube with sides of area a. The average vertical component of the velocity of the gas molecules is v, and n molecules hit the side of the cube in a timer delta t. What is the pressure exerted by the gas on the bottom of the tube? So the primary things that you need to solve this problem is you need to go back to impulse or Gimpulse, where you have J is equal to F delta T and J is equal to M delta V. And because both of those equations equal impulse, you can substitute themselves into each other. And basically, once you do that, you just solve for pressure, and you get P. Pressure is equal to 2mv over delta T times A. Example problem like this that we saw previously was on the Unit 1 pre-exam, except it had to solve for velocity instead of pressure. So my error was that I did not recognize the correct, I didn't really know the two equations that were for impulse, because this is like the only outlet as to which we use that equation in general. So the correct answer is D. The next problem that I got incorrect was problem 4. This problem is actually very easy, just basically tests you on the various types of heat transfer. It reads, which mode of heat flow involves the transfer of thermal energy via one particle carrying a high thermal energy and traveling into a region of low thermal energy? So important concepts for this part of the test are, like I said, types of heat transfer. So you need to know conduction, what conduction, convection, and radiation is. And as listed, basically the most important one here is convection, where by definition it's the spreading of heat by molecules themselves moving from hot to cold, which is what the question directly asks. And a problem that's similar to this is problem 4 in the 1.6 group quiz. So the correct answer is B and not D, which is what my original answer was. Moving on, next problem that was incorrect was problem 7. This problem for me was a little challenging to conceptualize, but after reviewing my error, I think it makes a lot more sense. So the problem reads, a fan is running in a sealed, thermally insulated room. Which of the following best describes the temperature of the room? So something to note is the isolated system, thermally insulated system. So the temperature of the room is obviously increasing, so that eliminates answer choices C and D. And basically, this problem is some important concepts are the person solving this question needs to understand that the concept of the fan doing work to the system around itself. So as the fan basically moves the air around it, it's doing work to the air, which overall increases the kinetic energy of the isolated system, which in turn increases the temperature. So the correct answer for number 7 is A. I originally picked C because I did not recognize for some reason I thought the fan would receive work from the air, when in reality it's actually doing work on the air around itself, which overall increases the temperature and the work done in the room. I jumped a little bit ahead. So for similar homework problems, I could not find a specific one that was similar to this, but this problem has to do with isolated systems, adiabatic systems, kind of like PV diagrams in general, understanding what thermally insulated means. And you need to understand the concept of work done by a gas or to a gas, which is what this problem is testing. Next. The next problem that I got incorrect was problem 8. This problem reads, Which of the following is the most accurate statement regarding why metal surfaces feel cold to the touch, but wooden surfaces do not? Note, the thermal conductivity constant for wood is about 200 times smaller than that of most metals. So the primary concept being tested here is the conduction heat transfer method. So when a person's hand touches an object, the object that the person is touching absorbs some of the heat from the person. Kinetic energy from the person, which technically is heat, I guess. So the most important part in solving this problem is knowing the thermal conductivity constant that's basically attached to conduction, the heat transfer method of conduction, which is as shown by the slide. Q over delta T is equal to Ka delta T all over L. So this basically shows that if you set up a proportion between the thermal conductivity constant and delta T, you find that as you increase the thermal conductivity constant, you will decrease the temperature you'll decrease the temperature in general, which is what is happening to the person's hand. The metal is absorbing more of the kinetic energy, which in turn makes the metal feel more cold. So the correct answer for this is D, is D and not C. D is realistically the only correct answer because it's the only answer that says the object being touched receives the kinetic energy. The other ones say it transfers kinetic energy, the other ones say that it transfers kinetic energy, which is not how it works. So the correct answer is D. Lastly, for problem 13D, the problem reads, find the work done by the gas during this process. For simplistic in calculation, assume that the isothermal process is a straight line. It's probably a typo in there. So some important concepts to know here is that the area under a PV diagram is the work done by the gas or to the gas from the system. Another thing is, in this case, we're dealing with triangles, and the area of a triangle is half base times height. And along with that, if the triangle has a base, meaning that it's basically a full complete triangle and doesn't have a base underneath, you do not go all the way down to the to y equals 0. You stop where basically in the outline of the triangle. Lastly, this problem tests the correct units on values for calculations, meaning you need to multiply liters times 10 to the negative third, and you need to multiply ATM times 10 to the fifth to get kilopascals. So my error in this problem was that I did not recognize the 1/2 part in front of the base times height, most likely because I was rushing. So basically easy mistake to make, and one that I do not plan to make again. So to get the correct answer, you need to multiply 9,000 by 1/2, which will get you 4,500. So a similar problem to this that was shown on the homework. Homework's not really necessarily homework, but the lab, which I guess is homework 2, was the experimental value for the work done by the gas. There's a typo. World should be work. So the work done by the gas would be the experimental value in that problem, because we also found the work done by the gas using the ideal gas law. And that is all for my test corrections. Thank you for listening, and have a great rest of your day.